right now. Should be on page 194 for section 4.5. In section 4.5, we will find determinants of 2 by 2s and 3 by 3s. Determinants are used primarily and mostly in this section to find the area of polygons. The polygon we will find the area of in this section is triangles. So for the first few problems in notes and your homework, you're just finding the determinant. You don't need to know what it means or why we're finding it. It's just going over how to find it. And then the last few problems, or the last one we'll do up here, will actually be finding the determinant, which is the area of a triangle. So the 2 by 2s are pretty simple. If that is your 2 by 2 matrix, the way you find your determinant is multiply the diagonals. So you will do 2 times 3 here, and it's always minus for determinants, 2 by 2s anyway. And then you multiply the other diagonal. So in this case, 4 times 6. So what would we get? 6 minus what? 24. So our determinant is negative 18. So again, if this was an application problem and we were trying to find the area of something, then 18 would possibly be that area. But again, right now you're just trying to find the determinant. The only thing you really have to be careful with in this whole section is your positives and negatives. There's no variables. It's just multiplication, subtraction, and addition. So that's the only thing you've got to be careful with. So like for this 2 by 2, what's the first thing you'd multiply? 2 times negative 1 minus, and what would you multiply? 3 times negative 4. So again, you just have to mind your positives and negatives. So it's going to be negative 2 minus negative 12. So if you do negative 2 minus 12 and get negative 14, you're obviously going to be incorrect. That's really the only possible way you can make a mistake in this whole section, is just your positives and negatives. So that would become negative 2 plus 12, or what? 10 would be your determinant there. So that's the only thing you have to watch for, positives and negatives. Questions on the 2 by 2s? They're pretty simple. 3 by 3s are pretty simple too. They're just a couple more steps. There's a method on page 195 called expansion by minors. I don't cover that method. I just focus on the next method on the next page, the diagonals. It's similar to the 2 by 2s, and I think it'll just keep you from being confused. There might be a little more work to show, a little more things to write down, but I think you would if I showed you the other one, find this to be easy. So we're going to do example 3 there. So we have a 3 by 3 matrix. The other thing I like about the diagonal method, there's steps you can follow. And the first step in finding the determinant of this 3 by 3, or any of them, is you always copy those first 2 columns right over here again. So if you could actually highlight that and copy paste it, that's what you would do if you were working on a computer. So negative 1, 4, 0, 3, negative 2, negative 5. Now, so you do want to try to keep your numbers spaced about the same. Your columns and your rows about the same distance apart, because when you draw your diagonal, you want to make sure you're hitting the right numbers. So that's step 1, is just copy those numbers over there. Step 2 is draw 3 diagonal lines starting with the top left. And then you're just going to multiply each one of those. Yeah. So multiplying the first diagonal down, what would we get? Positive 4. And then the next one we always like because there's a 0 in it, so it doesn't even matter what the rest of the numbers are. And then the third number there, what would we get? Multiplying these three. Positive 60. And you do the same thing going the other way, diagonal. So we get 0 again, negative 5, and 24. Everybody still with me? So then, once you get those 6 numbers, you add the bottom and you subtract the top, which is again where some of you will make mistakes on your adding and subtracting. My advice, which some people chose to not listen to first hour and some did, you'll have to make that choice for yourself. I would put all 6 numbers down here with the correct sign between them. You're adding the bottom, you subtract the top, even if they're 0. Some of you can do it. A lot of people want to add these up and get 64 and subtract the top numbers. You can. You just have to be careful. Make sure you get it right. That's why my advice is just to write all 6 of them down there and type that whole thing in your calculator, putting minus negative 5 to ensure you end up with the right answer. We did check, I think it was number 6 in our homework. We checked, and I think there was about 6 different answers. So just to give you an idea of how many ways you could screw these up. Have to be very careful with your signs. So what do we have for an answer for this one? Anybody want to say? What? 45. 45 is the correct answer for that. So just make sure you get it typed in correctly. Rather than do another one, just a plain 3x3, we're going to go ahead and do the area example because it is another example of a 3x3. They're going to give you the vertices of a triangle. So they're going to give you 3 square pairs on all the problems where you have to do this. I'm going to write all this problem down. It's only in my book, but it says a surveying crew located 3 points on a map that form the vertices of a triangle. The coordinate grid in which one unit equals 10 inches is placed over the map so that the vertices are located at, and they give you the points, 0, -1, -2, -6, and 3, -2. So they give you those 3 points, and if you look at the diagram, either one of them on page 197, you kind of see what we're talking about. You've got those 3 points of that triangle, and you need to find the area of the region. And then remember, 1 unit equals 10 inches. Some of them will tell you that, some won't have anything. So if they don't, your answer is your answer. But if they do, you got to convert that at the end. So to find the area, you have to take it times 1/2. It's kind of like the area of triangle formula. And then you write your 3x3 matrix. These points right here are your column 1 and 2. You just copy them in there. 0, -1, -2, -6, and 3, -2. That's your first 2 columns, just your area. What goes in that third column? Ones. Third column is always just 3 ones. So don't forget your 1/2. Don't forget your third column is ones. Once you're at that point, then you solve it just like we did that previous example. So what do we need to do first to solve this one? Copy your first two columns over. Can we draw our diagonals? We get 0, -3, and 4. Everybody get that? So we draw our diagonals the other way. -18, 0, and 2. So what do we have for our determinant? Anybody have an answer? 17, did you get positive or negative? Positive 17. So a side note on your homework. You look at the formula on page 197, it says A, it's absolute value of A. You cannot have a negative area. So even if you would have ended up with -17 there, you know it's positive. It has to be positive. In some of your homework, you will end up with negative number there. So it's absolute value of whatever you get. So if it's negative, you automatically make it positive. So if our determinant then is 17, what do we have to do to that? Times it by 1/2 or divide by 2, which would give you 8.5. And then we have to convert that since 1 unit equals how many inches? So what do you think we would do there? Times by 10 and get 85, except this is area. So what would this be? Squared, right. So it'd be a 10 by 10 or 10 squared, which is 100. So you don't take it times 10, you take it times 100, since you're talking about area in square inches. So 850 inches squared or square inches, however you want to write that. Don't forget that part though, because some of your homework will have that. It'll have equals 10 units. Make sure you square that before you multiply. Now number 7 and 8, for instance, on your homework on the next page, it doesn't say anything about how many units equals what. So that's just whatever answer you get if your answer. But down on 26, it says 1 unit equals 10 miles. So that one will be very similar to the one we just did. Homework problems 1 through 30. We skip number 29. Any questions on any of those before you get started?